Hello everyone, hope you're doing and welcome back to my channel. This video is actually a continuation of the previous video that you have seen. Okay, this is regarding the day 10 December daily lead code challenge. I've already given a whole explanation of this question, and also I've given a solution that is expected for that question. Okay, it is around O of n square time. So this was the question because of the this particular constraint. I gave you the solution which is around O of n square time. You can even go for O of nq time solution and that will be accepted. Okay, but because we want to try something harder, for that reason I am creating this another video. In this particular video I will be showing you for the same question. I will show you a O of n solution. Okay, so that is both space and time completely O of n. So that the idea here is, even if you get see currently it is 50, right? Even if you get a length around 10 power 5 to 10 power 9, still you can give this kind of solution as your answer. Okay, that is the reason why in the other video I mentioned this is that kind of question which you can expect in a FANG level interview. Remember that. For that reason I'm uploading this another video, so that to highlight how much important this is, and it's why it is always needed, so that even see LeetCode gives you this kind of question, still it is important on your part to learn. If a solution exists of often, you should learn that. Okay, even though it is not required in this case, but still we will see a solution which is often, and even LeetCode has not given this kind of solution. Remember that. So this is something which is even beyond LeetCode. Okay, so let us see this now. So I am not going to the in details of the things because I've already explained them in the other video. So if you're coming to this video, I'm expecting that you have seen the previous video. Okay, so let us quickly question. So yeah, so like the only part that I want to tell you before going to selection is, for example, see this. So I am having 5 A's here. Okay, so this part I am hoping you are clear with that. Okay, that if you take a single A, it is present for the 5 times. If you take a double A, it is present for 4 times. If you take 3 A's, it is present for 3 times. So on. Okay, you can do that calculation, and I'm not going in details of that. So just another thing that I want to show you, that see, suppose there are 4 A's, you are having this. Let us say you are having a ready-made list. Okay, and you are going to get the 5 A's now. So what you have to do basically, what you have to do is see wherever, see what you have to do. This is the only additional thing that will come. Okay, rest all will remain the same. So whatever is here, just write them here as it is. Okay, and add one to them. Okay, that is, see, the single A, here it is 4, here it will become 5. Okay, similarly the double A's, here it is 3, and here it will become 4. Okay, as simple as that. Similarly here the triple A's, here it is 2, it will become 3. So everything here basically you can copy them as it is by just incrementing them by 1. Okay, you are going to get this part, and this will be the only new addition to that. Okay, fine. Now I'm coming to approach that we are now going to design. See here, let us say I'm having 5 A's. Okay, I'm starting to process them from left to right. Okay, so if I do that, what will happen? See, first I will see a single A. Okay, so I will write them like this. Then I will go to the second index. Then the idea here is I will get 2 A. That is, yeah, what happening is, when I'm in the second day, I already know that there was a prior to that. So for that reason, now I can mark this. Okay, I will mark this, that I've indexed a substring of size 2. Okay, which is following this property of special string and all that. Okay, fine. So what I know, that I have now currently a string, okay, which is of size 2, and that is indexes, that is frequency is 1. Okay, then I will go and process this particular index. Okay, that is the third A. So now this is the string that I have processed. Okay, this is the one that I'm highlighting, is the one that I have processed. So that is, I'm going to face a string of length 3 for the first time. Okay, a substring of face of length 3 for the first time. So I will mark this as a 1. Similarly, I'm going to face a length of 4, so I will mark this as a 1, and then finally the whole part. Okay, a substring of length 5, all ones. Now the question is how to go from here to here. Okay, please pay attention here. This is going to be very, very important. If you know this, only then you can think of the optimal solution. Remember that. So how to go from here to here? That is the question. Now how to do that? See, what I will do is, see, whenever, see, you have to start from right to left. That is the first thing. Why right to left? Because our aim is to get the longest special thing. Remember that. We do not want the shortest one. We want the longest one. Okay. So what you have to do? Start from right to left. Okay. What you have to do? See, first character, when there is one, you have to leave them as it is. Okay. After that, for all the other characters, what you have to do? For example, when I'm at this character, what I have to do? Take the value for the string which is right of it, there is 1, and add 1 to it. Okay, so it will become 1 plus 1, which is 2. Okay, as simple as that. Similarly, when you are at this string, what you have to do? Take the value at the right of it and add to here. It is 2, so it will be 1 plus 2, it will become 3 here. Okay, then again, now I have to process this part. I have to do this. Take the value which is at the right of it and add to the current value. Okay, so the right value to this is 3, so I will take this 3 and add it to this one, so it will become 4. Okay, I'm just writing at 4 here. Okay, fine. Next, what I have to do? Again, same thing. Take this value and add to the existing value in this. Okay, so it will become 4 plus 1, which is 5. So this is how you are going to get the actual string. That is remember, this and this are now becoming same. Okay, so I've explained you how to get this. So when you're processing from left to right, okay, initially we'll get the string that I've showed you before, and then how to convert from that string to this string is something that I am explaining you currently. Okay, I hope this part is clear to you now. So let us start to begin the optimal solution now. Before showing you the optimal solution, yeah, select, yeah, the same thing that I showed you. Now I will show you with in terms of example one. Previously I showed you with 5 ways, but now currently I'm just explaining the same thing in example one, so that you are now able to correlate when you when you see the output, right? You should be able to correlate what is happening. So in the step one, what I did is initially, basically I will come to this, but initially remember everything will be zero. So see, the idea here is, because see, in the other video, if you remember, I mentioned a very important point that, see, this part, the lowercase part is important here. Why? I will tell you this now. See here, the idea here is there are going to be only 26 characters. Okay, so any array that we are talking about, remember we are talking about special arrays. So we are especially saying this because special array here they are talking about something which is not repeating, right? Where the characters are not repeating. So there can only be, see, there are 26 characters, lowercase characters, right? So there can only be 26 special arrays. That is, uh, special arrays can be of only 26 types. That's what I'm trying to say. Okay, so what I'm going to do is, see here, what I will do is I will create a map. Okay, that is for a, I'm going to create a array like this. Okay, whose length is going to be the length of the input. Okay, like this, going to be length of the input. Here the input length is 4, so I'm going to create an array of length 4. Initially all of them values are 0. Similarly for B, I'm going to create another one like this. For C, another array of length 4 like this, and so on. Till that I will do that. Okay, this is the Z part. Okay, fine. Why I'm doing that? See, the idea here is, see, any substring. See, idea here is what, at max what can happen. All the letters can be A, right? So in that case, what I'm doing is, see, the first value represents a string of length 1. That is, this is basically the frequency of A's of length 1. That is for a single A, that is A of length 1. That is a substring which has A of length 1 has, what is the frequency of that? This is going to be represented by that. Similarly, this will tell me string of length 2, which has, that's, you can say, like, special subarray of length 2 has how many, that what is the frequency of a special array of length 2. This will tell me what is the frequency of a special subarray of length 3. Okay, this will tell me what is the frequency of a special subarray of length 4. Okay, after 4 we cannot go, right? Because the array itself, that is whole string itself of length 4. So we are going to track all of them through this now. Okay, so we are just trying to simplify the thing here. So this is how initially it will be looking. So initially, if you see here, it will look something like this. Okay, for A, all are going to be zeros initially. This is going to be the step 1. Okay, after that, what I'm going to do now, I'm going to start processing this part. Okay, this thing I already explained to you just now. I will again, let me show you that. See, first I will witness a single A. Okay, that is, now I'm going to append this particular value to 1. Okay, because I've seen okay, as a subarray, that is special subarray of length 1. So I'm, that is present only once. Okay, I'm updating that. Next I will go to this. Now this array, this is where I'm currently I have processed a subarray of length 2, of which all are A's. So I will increment this by 1, which will become 1. So see, I'm telling how to, from here how should we come to this. Okay, this is the step 2. Then I will process the first 3 A's. Okay, so then it will tell me that I have processed an array, that is special array of length 3, and the frequency is 1. So this should be made 1 after that. Okay, previously it will be 0, you have to make it 1. And finally, like this. Okay, it is of length 4, so this should be updated. So basically each place here tells me what is the subarray length. That is, see, this particular place will tell me that what is the going to the frequency of a array, that is special array which has A's, and its length is going to be 3. So this is going to the frequency for that. Okay, initially I'm marking them like this. So I remember I told you the same thing here, right? How we are going to get this, the same logic I'm going to apply it now. So what I'm going to do, same thing, take this value and add it to this particular value, so it will become 1 plus 1, which is 2. So I will write 2 here. This will be what in the case of step 3, remember that at the last step. Same thing, take the original value and add the next value to it. Okay, it will become 3 now, and then we will stop processing. Remember, this should have been 4. I agree with you. If you see in this particular order what you have done, it should be yeah, coming like this. Okay, so this basically should have been 4, but I will not mark it as 4. Why? I will tell you. Remember that we need only a, remember we need the longest special substring, right? Longest. So the idea here is the second, because right, remember we're starting the process from right to left. Okay, that is, we're starting the process from the longest to the shortest one. So the idea is the second we reach a length which is greater than, that's a frequency which is greater than or equal to 3, we should stop, because there's no meaning processing after that. Okay, that is, even if you process that, what you're going to get, you're going to get a string, that is a special string of length 1. But why should you need that? Because if you're getting a length 2, then why you want to go for length 1? Okay, remember you have to determine the longest, right? So again, once you know the longest is going to be 2, why you want to go for something below that? So no need to process that at all. Okay, so that is the basic idea. So idea is we only process the first, that is the last 3 values. Okay, we are going to do that. I will show the actual calculation, but just I want to give you heads up that what we are going to do now. Okay, so let us quickly see the solution now. So I hope this part is clear to you. I will give you this whole output. Initially, what we are going to do, we are going to see for each character, basically A to Z, we are going to keep a value of all zeros. The length of that particular list is going to be same as the length of the given input. Okay, first of all, let's see the code for that. So this is the code for that. Okay, I'm declaring this variable. This is, while processing the string, we will be using this. So what I'm doing, I'm going to create a map. Okay, it's going to be the map. You can give a better name also. You can give a frequency, something like the FREQ, something like that. So this is going to be a map. What is it is doing? First of all, I'm going for I in range this. I'm going to the ASCII values of A, from A till I'm going to Z. Okay, I'm going from the ASCII values of A till ASCII value of Z. And what I'm doing then, I'm creating CHR means the ASCII will be converted to a character one. That is, for each character now, I'm creating the value as a list. Okay, the list is going to have all zeros, and the length is going to be same as the length of the given string. Okay, I hope this part is clear to you now. Okay, this was the important part. If you are understanding this, the rest of the things are going to be very clear. Okay, next what I'm going to do. Next, I'm going to start the processing. Since I'm again going to start the processing from index 1 onwards, so for index 0, I'm going to manually append the value. Okay, what I'm going to do, see, go to s of 0, that is in the frequency area map, go to s of 0, that is s of 0 is going to be a character, right? So go to that character. Since, see, for example, the first character is just a length 1, right? So you have to append that value in the 0th index. So I'm again repeating this part. See here, the first value that I see is basically going to represent is going to represent the frequency of a substring of length 1. Similarly, this is going to be for length 2. Similarly, this is going to be the frequency for length 3 and something like that. Okay, so on. So you have to first append the by 0, because the s of 0 is going to be a length of 1, right? So you have to append this. You have to go to 0th index and you have to mark it as a 1 initially. Okay, then I'm starting on the 1th index onwards. Okay, what I'm doing, if s of I is equal to this previous character, what you have to do, you have to just increase this part. Okay, special substring length is equal to +1. Okay, if that is not the case, you have to keep it as 1, as simple as that, because this in itself is a substring of length 1, right? So you have to keep it as 1. If it is matching, that if it is the same as the previous character, what you have to do, you have to just append this part. Okay, fine. And then whatever we have got the new one, okay, this new value, we are going to add it to our existing value. Okay, that is, go to s of I. Okay, in that, go to this particular position. Why I'm doing -1? So remember, this means a length 1. Though it is index 0, it means a length 1. Similarly, this means a length 4. Though it is at index 3, but it means a length 4. For that reason, I'm doing a -1 here basically. Okay, special substring of length -1 plus equal to 1. Okay, as simple as that. Because now I have found a respectable substring length. Okay, for that reason I'm just doing a +1 in that. Okay, as simple as that. After that, I'm printing this array. Okay, after populating the special. Okay, let me show the output for that first. So this is where initially, now after populating the values, it will look something like this. Okay, after populating special substrings, okay, the frequency, it will look something like this. So it will, for the example one, it will look like this. Okay, all are going to be ones here initially. Okay, if you want to see some other example, let us say go to example 3. So it will look something like this. Okay, yeah. So if you see here, of a length, there is a substring of length 1 is present 3 times. Its frequency is 3. Similarly, substring of length 1, which contains b, is present 2 times, and this is going to be 1 time. Okay, frequency is 1, and so on. Okay, but let us stick to example 1 because it's a nice question, nice example. We'll stick to example 1 for all our descriptions. Okay, so here, as you can see, all are going to be ones here. Okay, rest all are going to be zeros in rest of the string. Okay, this is the one. Now we have to do the second level of processing. Okay, that is the now we'll come to step 3 now. Okay, how to get this. That is the most important part now. So yeah, this part is done. I've shown you the output for this now. I'm going to create the answer. Initially, I'm making it as a -1. Remember, if nothing works, we have created -1 as the answer. So for that reason, I'm starting it as a -1. Then I'm again going to the ASCII values from A till Z. Okay, I'm going from ASCII values from A till Z. I'm converting that ASCII value to the character value. So this character will be from A till Z. Okay, fine. Then I'm initializing a variable I is equal to n-1. Okay, why n-1? Because see, this particular what I'm showing you right here, like this. Okay, so what I will do, I'll start processing from the last character onwards, and then I will move leftwards. Okay, let's from right, I will move towards the left. Okay, the same thing I'm going to do now. Fine. So what I'm doing, yeah, while, see, the idea here is, see, the idea is going to be very simple here. So what will happen is, let us say something like this. So what will happen is, there will be some values, and after that there can be some zeros as well. Okay, so the idea here is we want to skip the zeros. That is, just a second. Yeah. So what will happen is we want to skip these zeros and we have to directly come to a place where we are going to see a non-zero value. Okay, for the first time. So that for that reason I'm using this while loop. See, there are multiple optimizations these are you can use, but yeah, these are not going to influence the time complexity as such. You can just these are just optimizations. So I'm running this while loop to reach a place from right towards left where I'm going to see the first non-zero frequency. Okay, as simple as that. So as you can see, till the frequency is zero, keep moving towards the left. Okay, keep subtracting I with a -1. Okay, as simple as that. Keep reducing I by 1. Okay, and you have to ensure that I has to be greater than 0 also. Okay, that is also condition here. So after that, what I have to do, once the I we come out of this particular while loop, that is we are going to reach a place where the frequency is non-zero. Remember that. So we are going to check if that frequency is 3. Basically, if that frequency is greater than or equal to 3, this could be a potential answer. So just consider this also for the answer. Take max of the existing answer and this particular thing. Okay, I plus 1. Okay, that is the reason. What is I plus 1, by the way? See here. See, this is going to the first non-zero value, right? So see, for example, this is the one, right? If this is greater than 3, let us say, okay, greater than or equal to 3, then this also could be one of the answers, right? So in that case, we have to capture the length of it. So what is the length of this? See, index is 3, but remember it represents a array of length 4, subarray of length 4. So you have to do index plus 1. That is the reason why I'm doing I plus 1 here, okay? You have to consider this also as the answer, okay? So this basically, I'm just considering this as the answer, as simple as that. Next, what I'm going to check, just one value before that. So this is for processing I, this is for processing I minus 1, and this is for processing I minus 2. Okay, only last three values I'm going to process. As I showed you, only the last three values will be processed. Okay, remember that, because within that I'm going to get the answer. Okay, as simple as that. Then I'm going to process I minus 1. If I minus 1 is greater than or equal to 0, then only process this part. What you have to do, take the value of in I, that is the one which is right to it. Okay, currently we're at I minus 1. So what is right of it? I is right of it. So take this value and add it to the I minus 1 value. Okay, as simple as that. After you do that, consider it for the answer. Okay, as simple as that. That is to check whether it is greater than or equal to 3 or not. If it is greater than or equal to 3, that particular thing is could be considered for the answer. You have to just what you have to do, same thing. I minus 1 plus 1. Remember what I did? Just to the index, I'm doing a plus 1. Similarly, here the index is I minus 1, so I'm just doing a plus 1 to it. Okay, as simple as that. Next, I'm going to consider the I minus 2. If I minus 2 is available, that is greater than or equal to 0, what you have to do? Take the value towards its right, that is I minus 1, and add the value to the current index. Okay, as simple as that. Then what I'm going to do, I'm just going to consider this for the answer. Okay, as simple as that. Take I minus 2 and add 1 to it, and this could be a potential answer if the frequency is greater than or equal to 3. Okay, we are done with this. Okay, after this, we are done. Okay, so see, that's why I'm pressing only the last three part. You can even introduce a basically see the idea here is if let us say this is true, okay. If let us say this is true, okay, and you updated this as the answer, what you can do is you can add a continuous statement after that, okay. That is no need to process the other two. That is also a good thing you can introduce. You can do that part also, okay. But ultimately, what will happen? It will do for all the Z, okay. What another thing you can think of is that maintain a set, okay, in that you are recording what are the characters present here, okay. Only for those characters, basically, do all this kind of processing, okay. Do all this processing because something a character is not present, there is no meaning to do this much processing for that, okay. So you can introduce that also. I'm leaving that on you, but remember that will not influence the time complexity again. So that's why I'm not done this. You can do that. So if you see this whole solution now, what is happening? So let us now discuss the time complexity of it. Okay, I understood. I hope you are understanding this whole part. Okay, this is how it will look and finally. Okay, this is how it will look finally. As I mentioned, we are only processing the last three ones. Okay, we are leaving this part because this will not be part of the answer. Okay, we are only processing the last three. Okay, because they are the ones which could be potentially the answers. Okay, for that reason. Yeah, rest all will remain the same here. Basically, in the example one, this is how it is going to be. Let's see for example 3 also. In example 3, finally this is how it is going to look. Okay, as simple as that. I will give you the session. You can run it and check it up for your own. Let me just explain the time complexity for now. Okay, so if you see the first part, I'm comparing the time complexity first. So this is going to be around O of n. Okay, do you agree with me? It is going to be O of n. After that, see this part here. Basically we are processing n. Okay, this is the n part. Okay, remember, for each loop here, we are processing O of n. Okay, so if you see the time complexity now, it is going to be n plus 26 into n. Okay, which could be reduced to O of n. Okay, because n is ultimately the higher limit. Because see, and see, in this case I'm assuming that, see, that one assumption is again there. So what is that assumption? See, n has to be in the range of around 10 power 5 to 10 power 9. Okay, for that, if you get this kind of cases, then this solution will be well used to you. Okay, remember that. Otherwise, this and the previous solution that I showed you will have the same running time. Remember that. Okay, that they will have the same running time. This particular case will be optimal. That is, it will make a difference only if you are having n of this frontage range. Okay, you can go to basically this part 2 of this question. Okay, and there you will get this question. So this is the answer for that basically. Okay, Fine. Now coming to the space complexity. So what is the space complexity? So see here, this is the one which is going to consume the most of the case. Okay. So what is the space of it? See, for each, that is, if you see from A till Z, we are maintaining a array of length n. Okay. So the space is basically 26 into n, which is again O of n. So this is basically how the both space and time complexity are coming as O of n. So what we are doing basically, we are creating arrays like this. Okay. And yeah, so each of them will represent the frequency of the lengths basically. There is a special subarray lengths of 0 till n minus 1. Okay, as simple as that. These are going to be the frequencies. So we are going to process them from right towards left, and yeah, we are going to get the final answer after processing the last three values, the last three non-zero values. Okay, something like this we are going to get. So yeah, and this was the solution. If you have not understood, no problem. Take some time. I completely agree. Remember, I mentioned in the start itself. This is a question which has the caliber to be present in a FANG level interview. So do not expect to understand everything in the one go. Remember, I've given you complete solution. Just spend some time, understand what is happening. I'm damn sure you will be able to understand this ultimately. I am, speaking very slowly. This is because I want you to understand this whole thing. Okay, so that's why this video might be a bit longer, but do not worry. I try to explain, I try to touch every point here. Okay, so that's why this particular question, I felt like this is something best we have seen till now in the December daily code challenge. That's why I spent so much time in this. Okay, I even gave a solution which is O of n, though it was not needed. Remember that the previous solution, it is around O of n square to O of n cube. That was itself enough to solve with this kind of constraints. But I gave you a solution to the situation when you face of a 10 power 5 range. Okay, in an interview, remember, you will get this. First they will ask you to do design for length of 50, then they will say like, okay, make the modification to even make it optimal for a range of 10 power 5 to 10 power 9. In that case, you will have to come with a open solution. Basically, you have to dump this whole code and start from scratch and come with this solution. Okay, remember that. So that is the reason why these things are important. This is a question which has caliber to be present in a FANG level interview. Remember that. Okay, interviews of FANG companies. So yeah, that was all for this video. I will give you this whole code below in the comment section. Go through it, check it out, and you will definitely get something to learn something more which you might not have seen before. That is my assurance. Yeah, that was all for this video. If you like my efforts, if you learn anything from my videos, please subscribe to the channel. It really gives a lot of motivation to continue further. Yeah, thanks a lot for your time. Yeah, see you tomorrow.